Hello, everybody. We're ready to start our regular workshops. We try to do this every month, and the topics are usually simple, concise, and our objective is to show you practical, util tools that you can use when working with data regularly. Today, we're going to talk about data analysis for machine learning. So it's kind of an excuse to combine data analysis with machine learning. Some of you folks might benefit from both the data analysis and machine learning part, but some others are just here maybe because you want to see a little bit more about machine learning, or because the data analysis part might be also interesting. So we are, again, live. I'm going to share my screen, and I will be walking you through the process of what we do. For now, what we're going to do is I'm going to... Oh, by the way, if you have any questions, there is a chat on the right. We have another folk checking it, so you can just ask anything you want there. If you want me to go over something again, etc., we can do it. We've prepared this workshop as a kind of a practical way of working. So we're going to give you a couple of notebooks that you will be able to execute, and you will be working with it. And also, after the workshop is done, there will be, after we're over with it, you will have a couple of other things to keep working on, right? So it's going to be really simple now that the weekend is coming. You have a little bit of a homework or extra activities that you can do over the weekend about data analysis and machine learning and all that. So again, any questions are welcome. Just hit the comment chat box, I don't know how it's called, and we're gonna answer them there. So I'm gonna share my screen. Give me a second. There you go. For those of you that are just joining, we will be doing the data analysis and machine learning workshop. If you have any questions, just use the chat box. We're going to answer all of them there. If you want me to, for example, rephrase an explanation or change the way we're doing it, or I don't know, check any extra piece of data, anything, just let us know there. So a couple of things. We are from rmotr. We do a live data science course with live classes every 2 classes per week. You guys know about us, so I will stop with the spoilers and the free publicity for now. But you can go check our website. We have a new batch that it is starting next Monday, and you can try the first week for free. So I'm just gonna say that if you like what you see today, especially our content, you can start our data science course next week, and you have 1 entire free week of trial. Okay. And also, for this workshop, we're going to be using this extra product we have. We created it for our students, but now we're opening for everybody. It's completely free. You can use and just try it out. It's basically a managed cloud-based Jupyter environment. Okay, so this is the repository that we'll be using today with these notebooks, and it is entirely hosted in this cloud-based product we built, so it's easy to manage. You guys don't have to install libraries, anything like that. Here is the repository. As usual, all our content is open source, so you can extend it, you can play with it, you can submit issues or fixes later, anything. If you find something in any way to improve it, etc., you can do it right here. There is a link that it's going to take you to a page where you will be able to create the project directly as we're doing right now. Okay, so if you guys click on this link right here, it's going to drop you in a page that is similar like this one. Give me 1 second. Sorry, I was checking on something. If you will be dropped in this page where everything should be pre-populated, make sure that you have your GitHub URL here, right? So it's gonna, when you create the project out of this GitHub repository, it's gonna pre-populate the content. Okay, so everything is there. You can just start working. There's no setup to do. Also, the name, the slug, the data science image, it's fine. You don't need anything extra. And that's it. You can start working. And again, you can follow us live. You can try things out on your own. You can keep working on these later. So let's get started 100% on the topics of the workshop. I'm going to restart our notebooks. And there you go. And we're going to get started. Today, we're going to talk about data analysis for machine learning because of a number of reasons. Machine learning is regularly simple to kind of write the code that is needed for machine learning. It's like, seriously, I'm going to show you an algorithm today. It's going to be just 2 lines of code, and the algorithm will be running. The difficult part is understanding what parameters to pass that algorithm. Okay, that's the complicated thing. You guys have, I don't know, a ton of data you're pulling from some extra source and getting it, managing it, cleaning it, manipulating it so you can fit it to your machine learning model is usually the most complicated step. I don't know what's the state of each one of you, what's the goal, your objectives, but usually if you're trying to break into the data science field, if you're looking for a data science related job, the simplest way to break into the field is by doing data analysis. Data analysis is usually complicated and it takes a lot of time, and some people don't want to do it. So there are a ton of data analysis related jobs you guys can use to get and to break into the industry. So keep in mind that it's extremely important to know how to analyze, clean, and manage your data for these purposes. Today, we're going to use probably the simplest machine learning algorithm, that is the linear regression one. And this is on purpose. And actually, some people don't even consider it a machine learning algorithm. This is on purpose because we want to show you how sensitive a machine learning algorithm can be to analysis. All right, so we're going to show you the naive approach to machine learning. We will try predicting house of prices without doing any analysis, without cleaning our data in any sort of way, and we're going to get a result. And then we're going to run through this entire and thorough process where we will be analyzing it, cleaning it, etc., and our results will increase by more than 10%. Okay, so that is the process we're going to follow today. The data set for this workshop is live in Kaggle. You guys can go pull it from there. It is also included as a CSV in our repository. And it is a simple CSV that has houses and their prices. Houses with their features, right? So you have a reference here of all the features included in each one of these houses, and also the price of each one of those houses. So for example, you have within the information for each one of the houses, you will have bedrooms or bathrooms or the surface area of the house. Let me show you that in action. So I'm gonna, I have to install something. By the way, let me do a quick introduction to this product we built. There's not a lot to talk about. If this is the first time you guys are working with Jupyter notebooks, or in this case, this is a Jupyter Lab, is an evolved version of Jupyter notebooks. It is nicer in terms of the interface, is a little bit more, easier to work with, and also has a ton of nice features like the one you have just seen. It feels now more like a full IDE for those of you that are used to working with, for example, RStudio. the this new version of Jupyter is going to feel a lot more familiar. So actually, I was trying to import a library. When you create your project and you select the data science image, we have already pre-included a couple of packages here. You can just use out of the box. But there's always something that we're missing, right? This is, of course, you have external libraries that you want to use, something in particular that you want to use. It's perfectly fine to just go ahead and install it. You can install it right here. So for example, within a Jupyter Lab, you can do something like pip install scikit-learn pandas is the package that we need to use in this for this workshop, or you could have done it also in here. So pip is also available in the terminal. This is a full computer for your own work. So we want to give you the full environment so you can start practicing and working right without installing anything. You can. This is of course in the cloud, so you can, I don't know, if you're migrating computers, if you are I don't know, on vacation, etc., you can always keep working, and you can keep an eye on your projects, in your data, etc. So let me show you first how these data looks like. I will be, again, we're gonna have two approaches. The first one is gonna be the dummy one, the naive one, and this is how our data looks like. This is, each one of these rows represent one house, one occurrence, one sample of these data set of houses. So for example, this is the ID of the first house. This is the price, number of bedrooms, number of bathrooms, surface area, number of floors, if it has a waterfront, the view of the house, condition. We have explained each one of these features right here. And of course, it is important. We're going to talk about it in a second. The first thing that I'm going to tell you is, let me start scrolling down here, is that we need, whenever we start a machine learning approach or task, we need to do a really quick, and actually, sorry, not just machine learning, any data science related task, we need a really quick check about our data. In this case, this data is external. It's something that I'm pulling from someone else. I cannot be sure that this data is clean, that this data is normalized, it doesn't have extra, I don't know, weird values, etc. So what I need to do is a really quick 5-minute check on this data. And usually it is just about checking the general form of your data, in this case, the shape, that tells you the number of rows. So we have 21,613 houses by 21 columns. So these columns are the features, we're going to call, of each one of these houses. So we know that a house Hey guys, I have just realized that I am muted. I can't believe it. I've been speaking for 20 minutes. Okay, we're gonna start over. Sorry about that. Um, so again, I'm gonna do a really quick introduction because we don't have a ton of time. We're gonna do a really simple approach of machine learning using machine learning and data analysis for machine learning. Our objective here is to show you this how simple it is to get started with this process. Only with a couple of minutes, you can pull our notebooks that we have already created. We have sent you guys the repository with it, and we're gonna give you all the steps required to follow our approach. And something else is that we've thought these as how to put it, as a really practical way. You can turn these and you can keep working on these later in your own house. Okay, so to get started, we have included, this is the repository. You guys can check it in our profile. There is a link right here. You can click it and it's going to drop you into this page. We have our own notebook service we have created for our students. This is completely free, so you can just follow it. And once you folks create the project, make sure that you include this repository URL. And what we're gonna do is create the project, and you will be dropped in this view. So everything is already cloned, and you can start working right away. For this workshop, we're gonna be using this data set that has different prices of houses. Okay, so it has a ton of different features of houses that they are listed right here: price, number of bedrooms, number of bathrooms, etc. And our objective is going to be predicting the price of that house. Okay, again, we can just get started. These libraries are already installed. What I'm gonna do is show you the different features of each one of these houses, and of course the final value we want to predict, in this case the price. We know, right, that some of these variables are going to be more important than others, and we've done already the 5-minute health check. That is all in my muted side of the workshop. But quickly, what I've told you is that in this case, we know we have 21,000 different houses. That is the shape that we're pulling from this data frame. We do a really quick check by only seeing the info result. The df.info gives us this information, the number of records for each one of the columns, and also the type of each one of the columns. Something for you guys to be aware of is what happens if you know that you have 21,613 rows. What happens if you have a smaller number here? The issue with that is that there is one column, or sorry, this column, if there are less records here, that means that some of these values will be not a numbers. They will be missing. All right, so the first quick check that you have to do is, if you know you have this number of rows, understanding that there are no missing values with any column. The second important check is understanding the type of each one of these features or these columns. In this case, we know that price is a float, and this is correct. But for example, date is marked as an object, that it's NumPy's way of telling you that this is a string. So if you check in detail the value, it does look like a string because it has a T in it. In this case, this data is well clean, so we don't need to do a lot with it. All these important fields are numeric. That is good. And the only non-numeric field is object. So again, the first 5-minute check that you do is understanding the shape of the data and a quick summary with information. Now, what features of these houses are we going to use in order to predict the price? That is a question. We know that some features are extremely important. If I tell you that without removing any other variable, I give you two houses and I tell you that one is larger than the other, you will assume that the larger house will have a higher price, right? Usually we know that, for example, square foot living, this variable, it's going to be important when you want to predict the price of a house. But what about other features, like, for example, the ID or the date? These are not necessary. They're usually not related to the final prediction or to the model that you want to use. In this case, we will be dropping a few variables, like, for example, ID, date, latitude, and longitude. We're also dropping latitude and longitude because there is another feature, which is zip code. So we're going to simplify everything with this zip code variable. Now that I have explained you the overall data set that we're using and the features that we're using, I'm going to switch to another notebook, this one right here, that has a dummy approach to these machine learning tasks. The objective of these data analysis workshop is showing you how you can improve your machine learning models only by analyzing correctly the data and performing a couple of actions with it. Okay, so this dummy approach will be just the naive version. We will do pretty much nothing in order to improve an analysis. I have the same data. I'm going to drop these columns that we know we will not be using, and I will create my linear regression model. Sorry, something else that I said when I was muted is that for this workshop, we're using linear regression, not just because it's the simplest model, but also is because it's one of the most affected models to a bad analysis. So linear regression will suffer if you guys don't normalize your data. It is really sensitive to outliers, etc. So that's why we have picked this simple machine learning model. Without doing any analysis, this is the part that I'm training the model, right? And what I can do is check the score of the final model. In this case, this is usually known as R-square score. And in this case, what we have is a 0.66 score. It's not bad. It's not optimal. What we will see is how to improve this number by 10% only by doing a really simplistic analysis but again, by taking into account the analysis part. So what we're going to do now is follow with our other notebook. I want you guys to keep in mind what we've done just in our other notebook was regular model without any optimization, without any analysis, without cleaning data, anything, just whatever we had, we ran it through the linear regression model, and we got a 0.66 score. We're going to see how that changes when we analyze the data. So the first step is understanding analytically how variables are going to relate to that predictor or that target variable that we want to understand. That is usually done with a correlation statistical. In this case, correlation can be either positive or negative. We usually say that something has a strong correlation, regardless of if it is positive or negative, based on another variable. So, for example, the square feet living with, oh, I haven't dropped, my bad. The square feet living has a 0.70 correlation, positive, strong correlation with price, and that is understood. The larger the house, the higher the price. Okay, so that is understandable. Some other variables will have negative autocorrelation. So no autocorrelation, sorry, correlation. So for example, crime rate. We don't have crime rate here, but if picture for a second that you do have crime rate in this data set, the crime rate, a higher crime rate, will probably say that the house has a lower price. Okay, so that is negative negative correlation, not autocorrelation. This is the value, for example, we have with correlation between square feet living house and also the price. We have, again, a positive value. I can use this quick plotting library, the Seaborn library, to plot these pyramid of correlations. And we can quickly see, aside from the ones that we know already, because the important part of data analysis is uncovering those hidden gems that you don't know about. All right, the worst thing that can happen when you're working with data is not knowing what you don't know. All right, so in this case, we could see these matrix, and maybe we can understand that grade and the square feet living variable, they have a high correlation, and we might wonder why. Or that, for example, the number of floors is negatively correlated with the condition, and there is something else that we should inspect. So again, the idea is to understand the data from an analytical standpoint. For example, you're built and the condition is negatively correlated, and this does make a little bit of more of sense. If the house is old, the condition is probably poor. Okay, so that is what we're trying to understand here. We can see how individual variables are connected or related. In this case, we are plotting, as we're doing a scatter plot, and we're plotting in the x-axis, we're plotting the surface area of the house, the living part of the surface area of the house. It's square feet living is a variable, and in the y-axis, we have the price. So here, we see a clear linear relationship between these two variables, right? The larger the house, the higher the price, that it has. Now it's also a good moment to start understanding about and talking about our outliers. There will be a few values in your machine learning model that will not make a ton of sense. So for example, what about this guy right here? Seems like a huge property with a really low value. Is that common, or maybe it's a mistake? Maybe this was the result of a data entry process, and this is an invalid value. What about grade? There is another variable that is grade. We know that the grade, the price of the house is related, it's correlated with the grade. The higher the grade, the more expensive that the house is going to be. But how they are related? Is it also a linear relationship? In this case, it doesn't look so. It looks like more of a polynomial relationship. As the grade is increasing, the price is not just increasing linearly, but it seems to be increasing kind of exponentially. We don't know, or polynomically, right? It's maybe there is another order there. So what we usually do in these cases is treat the y variable, in this case price, as a logarithm, right? So in this case, we have now a more linear relationship between these two variables. Here, I will make a pause and I will tell you that you can keep advancing with this analysis. I have just chosen only two variables, the most, obvious variables out of this data set, the surface area and also the grade. You guys can keep understanding the relationship between other variables. How is the price affected by the number of bedrooms, okay, or bathrooms, etc. So our fourth step will be to do a really quick cleaning process, or actually not just the cleaning process, that's going to be, of course, the result. The idea is to understand our data really quickly with a good overview, a 10,000 feet overview of the data. In this case, using the describe method of fairness, what you're going to get is a summary statistic for each one of the different features that you have. So for example, bedrooms we know that the average number of bedrooms in a house is 3.37. The surface area is 2,000 square feet, right? So this is the average size of a house. The standard deviation, the minimum, the maximum, etc. This is, again, really quick summary statistic of your features. This is also valuable because you will clearly and quickly understand what might be issues with your data. So for example, right here, I can see that a house has 33 bedrooms. Okay, that doesn't make a lot of sense. Maybe we should plot it probably and see if it is something that is completely crazy, something that doesn't make any sense, or it is possible. So in this case, what I'm going to do is plot two variables with box plots. These box plots are really useful to understand outliers in our data. In this case, a really quick introduction to box plots. It's giving you kind of a central tendency right here, and everything to the left and to the right of these two whiskers, that's the name that they to these bars right here, will be considered an outlier. So maybe this guy, it is an outlier based on the math behind the box plot, but it isn't too crazy. But this guy over the right, this is clearly an outlier. So let's see what's going on there with the house with 33 bedrooms. And what we find is that it is a house with 33 bedrooms with only 1,600 square feet of surface area. We saw that the mean was 2,000, so that doesn't make a lot of sense. 33 bedrooms and 1.75 bathrooms. What is that, right? So that doesn't make a lot of sense. This is probably a mistake when creating the data. Machine learning algorithms will be extremely sensitive to outliers. Okay, so sometimes outliers will be the result of just bad typing, something that went wrong, and at some other types they exist. Okay, but you want to leave them out. All right, so I don't know, when processing sport data, sometimes we decide to leave the 2-3 best players in the league. We decide to leave them out of our analysis because they are outliers. They play too well, or they score too many points that they are not representative of a regular average basketball player, for example, football player or whatever. So usually we try to leave outliers aside. Again, sometimes outliers are playing wrong data. You can just easily remove them. At some other points, they are valid points, and you need to make the decision. Will I be removing these faults, or will I keep them and see how the machine learning algorithm works? So in this case, I have identified that this house is the one with 33 bedrooms, and it's probably wrong, so I will just drop it, okay? And now I can understand other variables. And this is what I told you. These are all kind of outliers. There are properties without bathrooms, okay? That sounds weird when there are no houses without bathrooms. But then you start checking the data a little bit more, and you realize that it might make sense because they also don't have a lot of bedrooms, except from a couple ones here. So what these might be indicating is that among these houses, because the name was house, there might be, for example, warehouses or store units, and these ones will not have a bathroom. So the lesson here is understanding that you need domain expertise in order to do both data analysis and machine learning. Is this value valid or not? I don't know. I need to know where the data is coming from, and I probably need to pick up the phone and call someone in order to understand, for example, this case. There's a house that has 0 bathrooms but 1 bedroom. What are these guys doing, right? So this is crazy, but it might be valid. You can keep playing with it and understand all the variables. I have left you here another box plot. So for example, these points here seem like 2 houses that are too large, or maybe warehouses that are too large. So again, it's your decision if you want to keep them or drop them. What are we going to do with zip code? Okay, zip code is a number. Remember that I did the df.info. It is a number. Where is it? Right here. It is a number, integer 64, and I can actually show you the individual values. But the reality is that it is not a suitable machine learning number. Machine learning algorithms will just work in a really naive way. It's going to understand that a higher zip code means that it's more correlated, or actually or negatively correlated or positively correlated, but it's more correlated with the price. So it's going to give it more importance to larger values right here. And that is not the case. What we want the machine learning algorithm to understand is that maybe this neighborhood right here is better than this neighborhood right here. And the machine learning algorithm cannot just pick that up because it doesn't know about neighborhoods or maps or anything. This is an example of a categorical variable. Okay, there are some variables that are plain old categorical. They accept only a small number, a small subset of variables. In this case, when you have a categorical variable, what you will be using is a dummy variable that it's the topic that we're going to explore now. We had in total 70 zip codes. all right, or 70 different zip codes, all right? Out of our 21,000 different properties, we only find 70 zip codes, okay? They are all located within this area. How they are distributed, it's something else you can see. In this case, you see, for example, that this zip code seems to be the most popular one, and there is another one that is a lot less popular, has only like 10% of the houses. How do you treat categorical variables, not just zip codes, categorical variables in general? And other example of categorical variables can be, for example, I don't know, you have the sex of a person. It can be male or female, or the gender. You have 5 different genders. Or you have something like grading, and it can be, or something related that it's going to be, again, just a subset, a limited subset of values. How do you treat this categorical variables, within machine learning? We will transform them in dummy variables. And I will just show you how that looks, because it's the best and easiest way of understanding it. Given our zip codes, in this case, we have only one column that accepts 70 possible values, right? These are the possible values that zip code accepts. Converting it to a dummy variable means creating, out of one column with 70 possible values, creating 70 columns with only 2 possible values, all right? Either 1 or 0. So this house, for example, had this value in its zip code column. Now it has a 1 in that column and nothing else in other columns. So we will identify this house as being part of this zip code with this number. So now the machine learning algorithm will understand that these all have the same importance, all right? What might change the price of the house is that one zip code is more popular than the other, etc. But for the machine learning algorithm, they all will have the same importance. Now, moving forward, we're pretty close to it. We're moving fast, even though I stayed speaking for 20 minutes. We're going to now understand the concept of feature scaling and normalization, okay? Scaling features means what happens if you have data like this one, where the units of your values is really different. So in this case, we have 3 bedrooms or 2,500 square feet of surface area. These 2 variables have both different units, look really different. We are counting 2, 3, 4 at most bedrooms. We actually saw 33, but a square feet, like the smallest one, we could say, and actually I can check that, say df.min, for example. The smallest living surface area of one of these houses is 290, which is a lot larger than our numbers right here. So a machine learning algorithm will suffer a lot if our values are not scale, right? And if they have different units. When I mean suffer, there are different different possible outcomes of the machine learning algorithm or model. Some models are going to perform poorly with this type of data. Plain and simple, the score will be worst. Some other variables, machine learning models will work well when they are trained, but they take a lot more time in order to train. So that is the difference between, that depends, of course, of the machine learning model you have chosen. To scale these variables, we're going to use, from the pre-processing package within scikit-learn, we're going to use a class that is the standard scaler. I have left this line here so you can change the scaler. You can use, for example, min, max scaler. I'm going to also use standard scaler, or robust scaler. There are different ones, and there is a link here for you to go and read about it. What the standard scaler is going to do is it's going to subtract the mean and divide each one of the variables, and it's going to give you something like this: a value that is no longer, it no longer has a unit. okay? Because it is, again, scaling your values and is extracting the units. This looks like it will not work, but trust me, it's going to work once we scale the values and we put it to work. So kind of our final step here is building a model that will accept the scaling of these features. For that, we're going to use the data frame mapper class out of the scikit-learn pandas package. It's an external package, the one that I installed at the beginning. And the only thing that we need to do is, in this case, I have defined one scalar class right here. You can change it again. You can use, for example, I don't know, min-max or rust, whatever the one you want to use. And what we're doing is we're creating a data frame mapper specifying each one of the variables that we have and what scalar we want to use. In this case, I'm using standard scalar for the regular numeric ones, and I am using a label binarizer one for my dummy variables. These, the label binarizer one, will do for zip code the same thing that we're seeing right here. Right? It's going to turn a categorical column into a bunch of ones and zeros in a larger structure. The ones that I'm leaving as none, I don't want to do anything with these one. Waterfront and view, these are ones and zeros, and the year, I will just leave it as it is. I could have done a better analysis with year. For now, I will just leave it as it is. So now, what I'm going to do is split my data in testing and training. Okay, there you go. And we have a bunch of warnings here because some of these values that were originally, for example, bedrooms was originally an integer, is going to be changed into a float. But once I have scaled my data in xtrain and in xtest, I'm going to show you what xtrain is going to look like. Don't worry, it doesn't make a lot of sense, but it's going to be this huge, let me do shape, this huge model that now has 15,000 rows because I have split it, and we have 85 different features. Why 85? Well, because we had the original 20-something, and also we turned zip code into a dummy one. So there are a bunch of ones and zeros as columns in that new matrix that we're using for predictions. So now that we have split our data and we have scaled it, what I'm going to do is create the model, fit the data, right? Fit my X and Y from subsets from training, and now we're gonna see the score. As you can see, the score now is 0.79. Is much better. It's 10% better than what we have gotten with our regular, not analyzed data. Okay, so there is a big difference between doing some simple analysis. And again, I have only, for example, when we were checking the correlation between different variables, I only considered grading and price, or surface area and price. When we identify outliers, I only stopped to check bedrooms. So probably you might find other things to fix. Okay, so again, with just a couple of minutes doing a better analysis, I can improve the score of our machine learning process greatly. As a quick summary, remember what you're trying to do before you start your machine learning process is first doing a quick exploratory data analysis phase, where you are checking the shape and a summary of the information of your data frame, and then checking for outliers, doing feature selection. Sometimes you have to do feature transformation, which is a little bit of a more dense topic. And finally, scaling or normalizing your variables. So I'm going to stop for 1 minute, and I'm going to receive all the questions you guys might have before wrapping it up. All right, so that is pretty much it. We've done, again, it was really quick, but we have left everything so you folks can keep working on it. You can, there is each one of these steps you can move into analyzing other variables and hopefully improving this score. Again, we got 70, how was it? 79%, not percent. Our square score was 79. You can maybe take it above 80, above 90, if you're lucky. So that would be great if you can share it later. Remember, these, you can work on this data frame, or sorry, in this, with this data right away using this service we built for our students. You can quickly check it. It's still in beta, but it's working. And also our next data science course is starting. I'm gonna open it up. Is starting. Oh, no te puedo creer, tío. There you go. Our course is starting next week, and you guys have one entire free week to try it. Okay, 1 week of free trial if you want to say it. So that was it. I'm gonna stop the share screen.